Dear all, thank you very much for joining us. Today we have a very good surprise, having an international seminar being spoken in English. And Hashem Ghazzawi also joined Andrea Beer. She is a senior marketing manager of Rapita Systems. And Hashem is a senior accounting manager in the same company. He's going to talk about the criticality of software, okay? His qualifications: he has a doctorate in engineering from the University of York in England. He also worked as a research engineer in Airbus in UK as a part of his doctorate program. He has a master's in engineering from the University of Sheffield, and he has a bachelor's of engineering from the University of Cork. As I said, he's a senior account manager in the Rapita Systems. He works in the software safety of automotive, defense, space, and aviation. He also worked in Shell Step in the UK as an IT consultant as a summer internship. And he also worked in Tata Steel in the as a control and automation engineer. Okay. Well, Hashem, thank you very much for accepting our invitation to give your talk in our graduate program in applied computing in the National Institute of Space Research. And thank you also, Andrea, for joining us. I'm representing Rapita System in the marketing department.
All right. Well, Vijay, first of all, I'm grateful for your invitation and I appreciate your kind offer to come and speak with you, ladies and gentlemen. So good afternoon. As Vijay kindly introduced me, my name is Hashem, and I'm here to spend a good half an hour or 50 minutes with you to talk about how from a small research idea, you can have lots of collaboration, both in the academic level as well as on the industrial level. Technologies that are used in airplanes and aerospace engines that are flying with our software. I'll get to that a little bit in more detail. So it's really interesting that any research that you do at the university level that really would pay off. And of course, it all boils down to what's your passion from the research, whether it's hardware, software. So I hope after this workshop or seminar, you get a flavor of what does it really mean by transitioning from academia into industrial collaboration, including academic work. So yes, I am in the business world nowadays, but I am an academic by heart. As Vijay introduced me, I do have a PhD in computer science and previous degrees as well. So the way I would like to spend the rest of the time is to be more of an interactive discussion. The last thing I want to do is to provide death by PowerPoint, okay? So feel free to jump in and ask me to repeat any statements that I've done, or if you have questions about any company, any research project that I'm going to mention, if you would like further details, just let me know. The only request I have is if you can have your camera on. I can see plenty if you have your cameras on, so at least we can have more of a discussion. So I would like to start with the journey that I took to be in the place where I am. As many of you were when you were doing your undergrad degree, when your supervisors or professors ask you, what do you want to be in the future? Probably 90% of people who have advanced careers, they didn't know that what they are now is what they were planning to be when they were at first year in the university. You know, so when I started at uni, I did control and systems engineering, and that's a degree where you study pure nonlinear mathematics, feedback control, and all of these modules that I'm sure most of you are well aware of. And then after I did my master's in the control systems engineering, I chose to do a doctorate degree that is not 100% pure theoretical. And that's where Vijay, when he mentioned that I did a few years work with Airbus here in the UK, I was a research engineer, and that was part of my doctorate degree. So if in the future that you, ladies and gentlemen, would like to be in the industrial world or the commercial world, doing any research with some industrial flavor really would benefit you, because the assumptions you do in your research will be more industrial related rather than purely academically and theoretical. As you know, in any research paper that you write or you're going to write, you always start with, here's the assumptions. And as you know, also there is a gap between what the industry needs and what academia offers. VJ is having a smile because we both are in the same world where there is that gap. And of course, our job, the job of the future researchers, is to bridge that gap. So having that industrial flavor as early as you can in your research degree would really put you in an advanced level when you finish your research. And of course, at the end of my research degree with Airbus, I found the passion for aerospace, aviation, and where I am with Rapita now is really satisfying my sort of personal goals, where I wasn't aware that, you know, the business world of software is something that I want to chase a career out of. If you ask me, so you are a senior business or an account manager at Rapita Systems, providing software tools to aerospace companies, but you have a doctorate degree in computer science. So you in the one hand, if you break it down, I am a salesman, but also in the other hand is I am highly academically qualified. So in our world, and VJ can you know, attest of what I'm saying, when companies like NPE or any respectful research organizations, when you sit down with your future stakeholders and future partners or customers, if you want to say, and you want to listen to their research needs or industrial needs, first of all, you need to demonstrate that you are technically capable of understanding what their requirements are. And of course, having a PhD is not a necessity, but it's something that you can use to your advantage in showing your stakeholders and partners that you are in the same level of understanding their technical needs. Now, of course, in the business world, there are more incentives for you where you want to look into the commercial aspects and when you are going to get the orders and the collaborations up and running. But that's something that you can always learn and develop during your careers. And of course, it's all about the experience, right? So when I started with Rapita, the business world was relatively new to me, and that was nearly now 9 years ago. So we at Rapita, we mainly work with space companies, aerospace, defense, and automotive. What's the common denominator here? Is back again to the slide, the criticality of software. So all of those automotive, aerospace, military, defense, and space companies, their software is either safety critical, if it fails, people die, or it's mission critical, where if it fails, you have $2 million that disappear, and maybe someone will have a heart attack. But it's basically, that's the criticality here. It's either mission critical or safety critical. In industry, we follow guidance, compliance, rules, standards, whatever you want to call it. And our job in Rapita, we are in the business of providing the automation of how to help our customers, how to make sure that the software they are developing is supposed to be doing what's supposed to be doing all the time under all the conditions. So we work with the likes of Rolls-Royce, the aerospace jet manufacturers, with, of course, Embraer. I don't need to introduce Embraer for a Brazilian audience over here. And of course, their software is both safety critical and mission critical. It depends which part of the aircraft it is. So Rapita, we were founded in 2004. We are a youngish company. In fact, we are celebrating this summer our 20th anniversary. And now we are nearly 100 people. We are 3 sites. And basically, we work with the rest of the world through our distributors, and we work with Europe and North America, South America, through our offices directly. So, as I said, we are in the business of providing software testing, automation tools and technologies for space and aerospace and defense companies. I made this more space relevant because, of course, given the NPE relevance here, we do work a lot with space projects, and this is some of the logos that our lovely partners and customers are happy for us to mention. And yes, I'll get into details into what we do specifically with these ones later on. But again, what's the relevance between research and Rapita where we are? So in 2004, there were 3 postdoctoral researchers, literally any 3 of you, ladies and gentlemen, that you put your heads together and you find a new novel way of how to do software testing of embedded safety critical software. Our 3 postdoctoral researchers were exactly in the same shoes as you are. And they were part of the University of York here in the UK. And they were part of the real-time systems research group. So if any of you are doing research on real-time scheduling, you may have come across the books of Alan Burns or Andy Willings. Their offices are actually in York University, near the office where I was. So these gentlemen, the 3 postdoctoral researchers, they basically found a new novel way of how to provide the environment of doing worst case execution time analysis of embedded software running on embedded targets. Okay. From there, they commercialized that research into something that what we call now as one of our tools called Rapita. Again, let me rewind the clock back. It was 3 postdoctoral researchers. It could be any of you guys having together an idea of how to do something that is better than what the industry already offers. They commercialized this 20 years ago, and we have Rapita systems. We had customers who wanted to work with us when they were part of the research group at the York University. And of course, they were not allowed to do commercial transactions because it was an academic institution. And as any of you know, this is where a startup gets created when they want to commercialize a technology that they created. All right. And in the ecosystem of the embedded world, you have in the embedded systems or software world, you have the CPU platforms, and then you have the compilers, and you have the real-time operating systems. All of these are really important components of any software program that you will be part of in the near future, whether it's a space program, a launcher, or a jet engine, anything that you will be working with, as long as it's embedded, the real-time operating system, the compiler that you're using, the language that you're using, and of course, the final CPU architecture that you're going to run your software on. Whether it's ESA, whether it's any standards that you are following. It's important to design your software in an environment that it allows you to test and certify that software based on these requirements. Okay. So with these, we have been successful and public with some of the cool logos here. You may recognize one or two, or hopefully all of them. So I'll start with the right direction. NASA, we are still part of the Gateway, or its Lunar Gateway project, and they are using some of our tools there. And I'll get into this later on. We have OHB in Sweden. Also, they are using some of our tools. In fact, this came out of another research project that we did called AMAS. And the University Alcalá in Spain, again, they used our tools to be part of the solar orbiter. And that was also, in fact, with ESA. It was an ESA-NASA collaboration, such a very, very cool project. So AMAS over here is a research project. OHB Sweden was one of the, you call it primes or part of the research project. We as a company, of course, we can always be part of any research collaboration, whether it's with the EU or H22 Horizon. You know, the research world is huge in industry. And then the idea of it is, again, bridging the gap between what the industry needs and what the sort of the end customer, which is ESA, what's the standards of the software safety and software compliance that they need. And again, how can the suppliers in the industry, like Rapita, for example, how can they help getting or helping those customers or companies like OHB to adhere to the compliance from ESA. And in here, what we did is we basically introduced our tools to OHB Sweden and made sure that they have our tools integrated in their environment to allow them to do software safety according to the ESA standards, you know, the ECSS and others. This is, for example, where NASA, they've selected us for their Gateway project. This is not sorry, guys, a research project. For this particular one with NASA, this was a pure company called NASA contracted a supplier called Rapita to do proper work for them. This was not born out of a research project. So I wanted to give you a flavor of a company like Rapita. 20 years ago, there were only 3 people out of a research idea. And now we have big companies like NASA doing commercial projects with us. But we also have more research projects to work with universities, with research institutes, or with industrial entities like OHB Sweden. So the world there for research, taking your whichever research that you do into a commercialization or into an industrial component that customers or companies would need, you know, this is where it gets really exciting. So whatever your plans is in the future, either to make your own product or to join a startup, and there are plenty of startups in Brazil in space and in the aerospace domain, or if you go worldwide, or if you join a well-established company with many, many years, or a research institute, like, for example, MPE, and they have their launcher and satellite and GNSS departments. It's all fantastic work. So it's all down to, you know, what really makes you wake up in the morning, and all of these, what's your passion really at the end of the day. And again, all of these, you can Google I can send a copy of these slides to Vijay and he can circulate with you internally. All of these have helped us as a company to create a new technology or to customize an existing technology that we have, and we added extra features. So why am I saying this? Is because yes, we are a well-established company in the industry, but we do not detach ourselves from the research world. In any recession nowadays, if a company is not making profit, they always cut the R&D department. But everybody knows the R&D is the backbone of any company who seeks growth and seeks diversifying their products. Therefore, we in Rapita, we are all academics by heart, because most of us actually come with PhD experience in computer science or with lots of research experience in computer science or engineering discipline. So when we hear a new research idea, we jump on. Now, of course, we are a business, so we need to make sure that that's in line with what we are doing in terms of our company roadmap, and also it's in line with what our customers need. What's the point of building something that nobody wants to buy? Being completely honest and transparent here with you, the idea is finding the gap in industry and making something that would make the life of your partners and stakeholders and customers easier. And that's again why the formula of every successful startup there. Thanks to Andrea here, where Andrea is our marketing manager at Rapita. We've looked at most of the research venues or research projects that Rapita was part of. And mostly here, Rapita is an actual contributing component or partner of the project. We have been parts of other projects where we are only an engineering supplier to some of the companies who are the prime contractors. These terms, Vijay knows more about, where in every research project funded by the government, you have the prime contractors, and then you have the other partners, and then you have the suppliers to these partners. So you as a company, you are in good hands if you are in any of these layers of contribution. Some of those, especially the earlier ones here, the Socrates and Proxima, they really helped us to fund the technology of our tools. So the first tool, as I said before, was called Rapitime, which is how to do timing analysis of your embedded software code running with CPU, basically. For example, if NPE or the certification authorities, INAC in Brazil, or if you go to the FAA, or if you go to EASA in Europe, if you go anywhere, you need to demonstrate the evidence that your software does not run over time. The last thing you want to do is if you are running, if you are having a rocket, or if you have a manned space project, or if you have an airplane, the last thing you want is something freezes and then the software gets frozen and nothing works as you expected. Otherwise, people will die. So this is where the authorities are extremely robust in seeking evidence that your software is always safe. And the authorities also do not care about your budget, and they do not care what you promise your customers. If they see that your software, or even your hardware, but as Rapita, we focus on the software, that's our business. If they see your system overall is not safe enough, they'll say, we don't care, it's not safe enough. Go and come back again with more evidence. So the idea of these research projects and companies like Rapita is to ensure that our partners, our stakeholders, our customers, they are on the right path of how to make sure that the software they're building will be certifiable in the near future when they need to certify their system. And I'm sure you are following the trends nowadays where there are a lot of startups building flying cars and building electric vertical takeoff landing, like Eve Air Mobility, which is a spin-out from Embraer. And then you also have people like Archer and Joby. And that's the new cool technologies nowadays, or we call them the emerging technologies. These things are extremely scary from a safety perspective, because what are the regulations for a flying car? Imagine you are living in the third story in your building and you have a flying car next to you. What's the level of noise, for example? What if the car suddenly falls down? Forget cars. If you have the drones that are designed for logistics delivery, imagine Amazon have a 10 kilograms or a 10 or 100 kilograms parcel that's flying over your buildings, and all of a sudden the software freezes because your risk case execution time is not correct, and then the parcel falls over a park or a school of children. How do you make sure that that's always safe? There's a difference between my software is working and my software will never fail. Completely different, and the budget, the resources is an order of magnitude difference. In my world, we work with systems that there's nothing called, there's no software that is 100% free from bugs, okay? But when you have the probability of failure to be 10 to the minus 12, and you can do the zeros, then this is where we aim for. That's what EASA and the FAA and all of the other authorities are forcing our customers to make their software as very extremely low probability of failing as possible. These are the areas that I also see the trend in universities are introducing not only the theory of operating systems and the theory of embedded systems, but also what does it mean to work on a safety critical software? It's a completely different game. How can you make sure that your software is always functional under all of the circumstances? There are all of these projects that you see here are spending millions and millions of taxpayer money to help the world-leading companies, to improve the quality of their software. There's quality, there's software safety, there's functionality. All of these, they really take as much resources as you can imagine. I'll give you a funny example here. Most people, when they design their system, they allocate 70% of their budget on the software development and the hardware development. And then they leave the last 10-20% for certifying that system. And then when they reach the certification phase, they realize they need another 90% of their budget to certify the project, because it's a very non-trivial task. Again, having a system that's that's one thing, but having a system that doesn't fail, that's a completely different game. And from my humble experience over a decade in the aerospace and aviation and safety critical domain, there is the high demand here for young professionals, both in the technical world that are aware of systems architecture, software architecture, hardware architecture. I'm not even talking about AI, and that's the new cool thing now. How can you introduce artificial intelligence or machine learning or neural networks, you call it whatever you want to call it, into safety critical systems? How can you have Embraer flying an aircraft where the landing system is based on AI? How can you make sure that's safe? what are the requirements for that AI system? Does it have online learning while the airplane is flying? How can you make sure that while it's learning online, it doesn't come up with a stupid mistake and it thinks the runway is like something else and you have a crash? All of these things I've been to other aircraft manufacturers, and they have huge labs of how to train AI, and that's not even introduced in the roadmap of flying aircrafts, but it's on the way. So why am I mentioning all of this is because when you want to be part of an industry that they focus on the criticality of the software, be it automotive or be it defense, military or aerospace, or the new cool things like flying cars, flying taxis, or vertical takeoff landing aircrafts, the criticality of your system, whether it's hardware or software, there is a lot of demand. I cannot think enough of how much this is in need, that I can hear my customers are saying, we can't recruit fast enough for professionals who have a good engineering background of what does it mean to have a critical system or a critical software or a critical hardware. So if this is an encouragement for you to even think about choosing a research path or choosing a career or choosing a collaboration with an institute or industry to add AI or a criticality in your scope, it's something really worth considering, because this is where the stream of technology is going. Smart cities, smart this, smart that, cognitive cities, AI, all of these terms, at the end of the day, it boils down to the same word I said in the beginning, which is criticality. Mission critical and safety critical. These are the terms that would really make your research or your product or your collaboration something as successful and relevant to what the industry needs, or something that, yeah, there is a lot of people talking about it, but nothing is tangible. Nothing is what the industry is looking for. So it's, you know, it's not very perhaps an easy decision to make, especially for, you know, people with a lot of aspirations of what do they want to do in the future. However, hopefully with listening and speaking to people like myself, we are based in the UK, we work with Europe, we work with Brazil, with the US, with the rest of the world, South Korea. They are doing a lot of work and everything I've mentioned here, a lot of research work. So hopefully this will give you perhaps a flavor that in the future you can focus on criticality of software or criticality of hardware. As I said before, any research paper you produce, you always start with assumptions. When we in industry, we collaborate with research institutes and we look at the research papers, if their assumptions do not take into account what the industry needs, then we say this is, I don't want to say useless, but we say this is irrelevant. So what makes your research stand out is whether you're doing something, a young research, like these guys here, they were part of the York University, or if you have a completely well set up, respectable research institute like NPE, the assumptions for your project that you do are always industry related and industry relevant. This is where other companies, international companies in the UK and Europe, will be wanting to work with you. And also, if you put it in your CV, in your research curriculum, or in your research achievements, that you have been involved in such industrial projects and projects that were funded by EU projects or Brazilian projects or whatever government funded projects, with relevance to what the customer stream is, or the business stream is going for, you know, it will make your CV stand out. It will make your research stand out. It will make your research institute stand out. And of course, VJ can add more here of what does it mean to have somebody with 100% pure academic background or somebody with academic and industrial backgrounds. If you want to recruit somebody in a startup or in a respectable, company, it's clear which one you're going to work with. Okay. This is my last slide. There are more, but really this is more where I can describe more in details how our tools help customers or people like NASA, ESA, OHB, or Embraer. We have active projects with Embraer and it's public, so we can talk about this. It's really up to you, ladies and gentlemen. How would you like to take this forward? Is it interesting for you if I describe what does it mean to do software testing and software verification? And what does it mean to do compliance to software safety standards like DO 178C, that's for aerospace, or ECSS for space projects? Is that interesting, or would you like to talk about other topics, more like research projects, or some examples from my personal experiences? I really want this to be more of a discussion rather than, me going through slides. So what did you find most interesting from what I talked about so far?
Any suggestions? Se vocês têm alguma sugestão para ele continuar, por favor?
Excuse me, Dr. Ghazzawi.
Yes.
In that regard, I would like to know more about. I was reading your CV, and I saw that you were also a postdoc, right, for a while, and I would be interested to know what's your take on the transition to kind of the academic life to the industry life,
Yes.
doing research in academia. You already told, right, about the differences, but can you extend your take on that?
Absolutely, yes.
Thank you very much.
Yes, Jonas. It all boils down to when I started my PhD, it was an industrial PhD. In fact, it's not called a PhD, it's called EngD, which is Engineering Doctorate. So my sponsor was Airbus, and I was physically placed inside Airbus and how to solve an existing problem using state-of-the-art academic theories. And therefore, my parameters of assumptions and my environment was very industrially influenced. So if I would make any assumptions that it will cancel out some of the problems that Airbus is having, then my supervisor would have told me, no, we want that assumption, which will make my research even more complex. Hence, they recruited me for that research. So when I was doing my research there and afterwards, after my PhD, nothing really changed for me because my path of research was in the beginning industrially related and industrially relevant. And back again, the assumption that I was working with for Airbus, it was for Airbus. It wasn't an interesting academic idea that I just thought about in the university and bingo, I did some research. That's also very useful and very relevant in general. But I was more focusing on how can I make an academic state-of-the-art theory in control theory and real-time scheduling. How can I make that to solve an existing industrial problem? And my sponsor was Airbus. So then after the PhD, the world of work, it did change a little bit. That's normal, but the ethics of research stayed the same, because it's the same assumptions. And then you can quickly, when we collaborate, I can quickly disqualify some of our research partners simply because the assumptions they make, they're not useful for us. I'll give you an example. So it's very interesting in an academic world, especially in our niche world. And our niche world is how to work with safety critical software on embedded CPU architectures, okay? So you want to say, oh, I would like to know what is the worst case execution path, or what is the worst case execution time of my piece of software running on a CPU target. Okay, so one assumption you can start with is, so let's start with a model of my CPU. And that is a mathematical model of your CPU architecture with the compiler and the memory mapping and everything else. That's fine. But this is not useful for me. I'll tell you why. Because the FAA published a technical paper saying, because of the advent of multi-core processor architectures, and multi-core processor architectures are very complex piece of architectures. It's because you are having different cores fighting for the shared resources. And this is a little bit low level for me, but please bear with me. So in a multi-core CPU architecture, when you have multiple cores are fighting on the shared resources, this could be level 2 cache, this could be your DDRAM, this could be your bus, for example, the interconnect. All of these are shared resources. So if you run a piece of application on core 0 and another piece of application on core 1, they will be fighting for the interconnect and level 2 cache. So your certification authority would say, Jonas, give me the evidence that your application on core 0 will always be deterministic, regardless what is running on the other cores. That's a very interesting piece of research. So if you come to me as a research collaborator and I say, of course I can help you there. Now, let's start with an assumption that we have a mathematical model of the CPU architecture. That's the first assumption. But that's the first where you say, I'm sorry, I'm going to disqualify you, Hashem, working with you, because having a mathematical model of a complicated piece of architecture is not suitable for me, because I need to understand the dynamic behavior of your CPU multi-core architecture to help me, then me as Jonas, understand and do the evidence for the certification authority. What is the execution time or the timing analysis of my application running on core 0 and core 1? So this is where it depends on the parameters that you're playing with, and it depends on the dimensions of your assumptions. We work with companies who they have similar mentality and similar research orientation as us. So the transition there is a little different, but not a lot. However, if you come from a pure theoretical computer science background, completely theoretical, and then you go to a company like Rapita, where we need hands-on research to help with active industrial projects, you will find a little bit of a gap, because you are used to make assumptions to simplify some of the complexities in the problem that you're working with. But now when you work with companies like Rapita or some of the industrial projects with MP, you realize, ooh, now I need to worry about these. And I always thought these are black boxes, but now you need to open the box. So this is where then you can see, I'm not going to collaborate with this company because they're not helping me. Or I'm not going to read the research work for that researcher because it doesn't really help my research nowadays. So it makes, to answer your question, really, it makes you more open and aware of what is the problem you're trying to solve now, and leaving the nice world of theoretical science. theoretical science is beautiful, don't get me wrong, but when you get your hands dirty on real industrial projects, and you have a customer and and a certification authority behind you saying, give me the evidence, you're not going to say, let's assume we have a mathematical model of my multi-core CPU architecture. It's not going to work. I mean, I can spend hours talk about examples of why such assumptions do not work in industrial life. However, I'll give you one quick one. For those who have background in embedded systems, imagine you have a two-core system that is fighting for level 2 cache and the DRAM and the rest of the architecture. So we've done experiments where we've run a piece of software on core 0 and we measured the execution time, and core 1 was empty. And then we took the same piece of software from core 0, we put it on core 1. You would expect that the execution time will be the same. It's the same CPU architecture, but different core. The manual of the chip manufacturer told us if you run the same piece of software on different cores, you're always going to get the same execution time value. By design, by the mathematical model, that's what's supposed to be doing. But we found out with thousands and thousands of experimentations, and it confirmed that no, when you run the same piece of software in core 1, it always takes more time than if you run the same piece of software in core 0. We were like, that doesn't make sense. So then we found out that the bus is not fair, which means the document says the bus is always fair, but of course the chip manufacturer did not get this right. So what happened is there is an extra function inside the bus that said the bus is always preferring core 0 over core 1, which means if you run this piece of software in core 0, it will get instant access to the bus. That's fine. Then if you take the piece of software running it on core 1 and you execute it, the bus will tell core 1, hang on a second, let me check core 0 if it wants me. So that delay is introduced in the execution time. So then if you do the mathematical model assumption, you go to the cert authorities, well, here's the evidence. And then people like us, Rapita says, no, but we found the evidence that the software on core 1 takes more time. The authorities will tell you, Jonas, you need to give me evidence that your software is deterministic, whether you run it on core 1 or core 0. So this is where it goes beyond your software design, software architecture considerations. It's something that you never even thought about. But you have a stakeholder waiting for you, an authority waiting for you with the evidence. And that's what keeps us busy with the research and the bright people that we work with. This doesn't exist in the academic world, by the way. This only exists in the world of safety critical. So even people like NXP or the chip manufacturers, they say, you guys in the aerospace world are very crazy. You focus on the very small features of the microcontrollers. Even us don't worry about it because we have certification authorities behind us that, you know, they expect evidence that the software is always functionally and temporally correct.
Oh, thank you very much, Dr. Ghazzawi. I really appreciate your answer and the connections and the paths that you explain, and especially after when you mentioned about the gap. Yeah, I to be honest, I have a question about that, but I noticed that I have a colleague that want to talk. So maybe if we have time in the end, I would just like to ask you a final question. But thank you very much.
All right, no problem. You're welcome.
Geronimo?
You mentioned you have a colleague who wants to ask a question.
Yeah, there is Geronimo.
Hi.
Hello.
Thank you very much. Thank you very much for your time, for doing the presentation for us. all appreciate it very much, and I thought it was great. So thank you. You mentioned a little bit in your presentation about machine learning. Could you elaborate more on that? I mean, how? I mean, on your how you use it on in your work. I mean, if you could. And I thought it was very interesting when you mentioned the gap between, when you're in an academic environment and then you go to the industry. Back in undergrad, I had this professor. He went on leave for a time because he wanted to start his own company, and then sometime after he left the university, we were talking to him, and he was like, "You see, I can, develop a machine learning system very well, but I realize I don't know how to make a product out of it." So I thought it was very interesting. I mean, the stake of your that you mentioned. I mean, between this gap between the industry and academia. So, but I would like to hear from you how machine learning can help these critic systems that you've been working with. And thank you very much.
Oh, you're welcome. You're welcome, Journey. So the use of AI systems in safety critical systems has not been completely figured out yet. It's not safe yet to use AI inside airplanes. I'm talking about the safety critical part of airplanes, like the flight control, the fader control, the jet engine control, the cockpit displays, all of these high critical systems. Why it's not been allowed or certified yet? Simply because in aerospace world or the space world, you have something called requirements-based testing. So from requirements, you develop your software. And then from the same requirements, you develop your test cases. So the evidence is you run your tests on the software with respect to the requirements. So that's requirements-based testing, okay? If you bring AI, the problem with AI is AI thinks by itself in a way that, yes, a human being will be programming it, but it doesn't follow a certain requirements. For example, any piece of software you say, in the case of switch case, if the door was open, do this alarm, you have different loops, and that's it. And you have statements, branches, decisions, and really that's it. You can be as complicated as possible if you want. But with AI, is you have a fitness function, and then you have the operators, and it may come up with a decision that in that particular real-time thinks that the best decision with respect to the fitness function, but it doesn't go back to your requirements. So the problem really is, how can you certify an AI system that does not adhere to requirements-based testing? So that's the problem. We don't know the answer, and no one in the market knows the answer yet. However, what Airbus is doing, and tell me, yes.
That was actually very interesting, and it's a kind of a different context. But if you could talk a little bit about it, because when you were talking about this thing about AI coming out with a decision that it maybe not be fit to the test cases, for example. I remember that Tesla earlier this year, they released their self-driving system. I mean, the new version of their self-driving system. I mean, what's your take on that? I mean, because it's kind of a critical system. I mean, if the car decides to go off-road, I mean, it might kill someone or cause some trouble. I mean, what's your take on that? I mean, if you have any.
Of course. So the problem with automotive world is they have self-certification, which means if Tesla, Toyota, Mercedes, they want to release a new technology, they just release a new technology. If you have Airbus or Boeing or Embraer, they want to release a new aircraft, they cannot just release a new aircraft. They need to certify the aircraft under EASA or FAA or INAC or whatever certification authorities. So the quality of the software from the aerospace world is extremely high. It's the highest ever. So you are much less likely to die if you are in an airplane than if you are riding a car. So aerospace software is this high, and then you have a huge gap, and then you have automotive. So with Tesla, they can introduce AI, of course, and they can do some average testing. And if it works, 8 out of 10, 7 out of 10, they're happy. But with aerospace, it's completely different. You have to have lots of redundant systems. Redundant means if this fails, engage computer B. If that fails, engage computer C. So that's why aircrafts are extremely expensive, mainly because of not just the hardware, but also the amount of effort that's been spent on safety. So I don't know the exact technical details of Tesla, but what I know is I will not trust 100% any autopilot, period. Whether it's in a car or certainly not in an airplane, because in an airplane, they have no chance. They need to certify. What I know as part of an R&D initiatives from the leader aerospace companies, they are using AI on the offline mode, not online mode. And the difference is in offline mode, they train the subset of your network to extreme amount of scenarios. And they think that is exhaustive, which means that is sufficient. And they launch that inside the flying aircraft, and that's it. So think of it as a completely very complex piece of F-nested functions, but that's the best they can do, unless they figure out how to certify an online active AI algorithm, and at the moment there's no answer. But it keeps us busy at Rapita, but we have other also priorities in our roadmap that we are thinking about. But this is one of the problems that we're thinking about, and we don't have an answer yet, and no one has. That's why you don't see an AI flying system. Sorry, an AI flying system with a critical software.
Okay, thank you very much for your answer. Again, it was great.
You're welcome. No problem. Thank you. Luisa, I can see your hand.
Hello.
Hello.
You are listening?
Yeah, I am. Yes.
Yeah. I have a curiosity. First of all, thank you for your lecture. Thank you, Andrea, for being here too, and for all your projects that you're doing. It is amazing, and it's very excited that you make a partnership with the NASA for the getaway.
Oh,
this
yeah.
is huge. Yeah.
Yeah, indeed, it is. It's very, very
Yeah,
cool.
it's very huge.
Yeah.
Congratulations to you.
Thank you.
I have one question that is inside of this context of space exploration, and for being the future for this. I know that right now we don't have a concept of habitats right now that is certified or have some requirements that attending this.
Mm-hmm.
But we are working for this, and I don't know if the Rapita systems can be in the future doing some certifications for these habitats, because one thing that I know, like being an analog astronaut that I am, it's
All
being
right.
in, yeah, it seems that we have habitats in the world, but we don't have some parameters for being requirements, like this is a good habitat for doing this kind of experiments, and this is impacts in the doing some experiments that can be used in the future for space exploration. So this is a little bit of the context to you, and to provocate for I don't know if it's possible to apply your systems in some of this kind of habitats that for in future being some reference for doing habitats in the moon or the Mars or something of that. Thank you.
Yeah, no, thank you for your question. That's very interesting, and there is one fundamental difference between the system knowledge and the system certification. I'll give you an example. Our tools, as you see here, they will show you 100% evidence that your software or your system is behaving as you programmed it to behave. So if you have a requirement, if the aircraft or if the rocket is 100,000 feet above, open the door. Now that's a completely wrong thing to do. But if you tested it that way, and if you have a requirement to say this, and you test your software, our tool will say, correct. So there is the human knowledge that you can never replace. And this is where it's important to have that interaction where you can have the know-how of the system requirements translated into engineering assumptions or in engineering requirements. And then from there, you can have tools like this to make sure that that's certifiable. So in theory, the tools will be only there to automate some of the manual testing that you need to do. But you as a human being, as the expert, you own the process, you own the product certification. And it's ultimately your decision to sign off and say, yes, I am happy with this or not. So I'll give you an example. So the FAA and the EASA, the certification authorities, they allocate one person or a team to be the middleman between the authorities and the company that is wanting to certify the product. That middle layer is the person or the team responsible of the safety or the certifiability of that product. They sign it with their names on, and it's a very big responsibility. So when they sign it and something goes off or people die, they are the ones who will be questioned, and they should go to jail if people die under a system that they said that's safe to do. I am going to bring the famous example of the unfortunate Boeing 737 MAX. But the problem with 737 MAX is, as you all know, it's not an engineering problem. It's more of a political organizational problem. Just like the Apollo failures, where the engineers were screaming, the rubber sealant is not strong enough, but the big manager says, come on, we need to launch and forget about safety. Unfortunately, you see this in big companies like NASA, Boeing, and other companies across the world. But this is where we still cannot 100% automate that piece of work, because you need a human being to own that process, and only a human being can justify whether it's a yes or a no. But in principle, yes, we would love to be, and this is the perfect use case where our tools or us as a company can be introduced as a partner with some of these collaborators that you have in mind, to say, what can we do together? We have the technologies, you have the requirements and the expertise. I'll end my answer with one message, we tell our customers the following, Luisa. We say, you should focus on building software for aircrafts or rockets or space systems. And you shouldn't spend your time on writing tools like these tools, because people like us in Rapita, this is our business. We automate the manual work, but you should be spending time owning the product, owning the system, owning the certifiability of the product. Does it make sense? Are the requirements healthy? In all of these things, that's your job. We take the boring stuff out of your work and we can automate it. It's not boring, but you know what I mean. Yeah.
Okay, thank you. This is awesome because it's something that I was wondering that the biggest step, for we are doing this kind of exploration is the requirements. We are doing this correctly, and it's fast. The technology was advancing fast, and we are not accompanying with the politicians and the policies that is concerned for this, So yeah, I don't know. I think we are very slowly in this, and this is very dangerous.
Well, it's always part of the mindset. So it's never too late to introduce such concepts. And we have academic programs, and I talked with Vijay about also other collaboration that we can do. Yes, we are a business company. We work with NASA and Airbus and Collins Aerospace and Rolls-Royce, but we also work with academic institutes. We provide our technologies for free. So this is not something for me to make business out. This is something for me because I found it extremely, we as a company, not only me, Hashem, we find it very engaging and useful. And it's also beneficial for us to know what is the state-of-the-art research, what's the trend they are going to. And, you may learn from us how to do software certification, but we also learn from you what's the state-of-the-art research going. So it's always a mutual collaboration there. So I'm sure you can get my contact details from Vijay, my email and the rest of my contact information. So everyone, really feel free to connect with me and understand more. How can we perhaps do research together or just stay connected? And I'm sure our roads will cross at some point in a conference, or if I visit your beautiful country, Brazil. Are you all based in São José dos Campos, or are you around the country?
I think most of them are based in São José because now it's not anymore online except the seminar.
Okay.
Okay. Okay.
Well, hopefully next time I make a seminar.
That would be very great. That would be very great.
Yeah.
Just to ask you, see, we have a sandwich doctorate program. Means the students who study for doctoral programs at INPE, especially in our course, there is a chance of accessing some funding from the Brazilian funding agency, CNPq or CAPES, or even FAPESP. If there is the chance of, trying to, associate both the interests of our students and your company,
yes.
Would it be possible for you to host the student for 6 months to 1 year to develop along with some supervisor, such as you, to work on some joint agreed project that could be a part of the thesis here?
The short answer is yes. The long answer is we do have students for 1 year or 6 months. Sometimes we work with academic institutes as well, where it's a good investment for us and them to accelerate some of the technologies by outsourcing that technology development to the research engineer. It's good experience for them, and it's good experience, and it's a good result for you because we're developing something for you. It's also good it's good for us because it's part of our roadmap. And I think it all boils down, Vijay, to what is the research idea?
Yep.
And
Yeah, of course.
So,
of course.
but in principle, absolutely yes.
Okay, that's good. That's a good idea because see, nowadays, it is not that common like in England or US or Canada, but there is slowly the increasing interest for the industry to hire people with a doctorate. Okay. And in this case, a doctorate program which had an experience, which has an experience exposed to an industry or company that might make a difference for the student after his graduation to get a job in a company. See?
Yeah. I mean, it always helps because with a PhD, you demonstrate that you have a very detailed level of experience in a niche area. As you know, Vijay, you supervise a lot of students, and at some point, the student knows more than the teacher.
Oh, definitely. Thank God.
Exactly.
Thank God.
No, we want more of these research bright engineers because our market is very demanding. It's very demanding. Yeah. In a good way, of course. So I hope this gives the encouragement to undergrad and postgrad students to reconsider research ideas with criticality in mind.
No, that's a good thing. For example, we're talking about the student becoming better than the researcher. I usually, my students, when the student discusses with me, okay, well, this is what I'm doing, this and that. I say, okay, is it that? I didn't know that. Thank you. Because they get worried. What? Don't you know what I'm doing? No, it's your problem, not mine. So it's like that.
Well, they've been spending day and night in the lab for 2 or 3 years working on the same research idea. So they own that research component. Yes, 100%.
I don't know how does it work in England, but for example, Embraer here does an excellent job setting up a project, a contract between ITA and Embraer. You see, ITA has a professional degree, master's, okay? They charge for the degree, okay? But the contract with Embraer is such that the student doesn't pay. An employee of Embraer is selected. Embraer pays the institute, as well also they also pay the teachers involved in that program. So the student and the supervisor from Embraer, they work together with the faculty member of ITA. They have a problem that has to be solved. Okay. Sometimes it is confidential. So what happens if it is confidential? The thesis doesn't have important information because that is hidden, or they use some dummy example. So this has been a great success between Embraer and ITA. Unfortunately, in pay, it did not go through because we don't have a professional degree. And the students with their own interest to go for master's and doctorate, in many a case, they finalize it. But in few cases, they had to abandon the program because the demands for Embraer, they have to go to China, they have to go to Canada for 1 year. So they have to cancel unfortunately, the enrollment.
Yeah. The involvement between us and research engineers have almost always been through government-funded projects.
Okay.
And then they allocate the research engineer or student at Rapita for some time to work with us on some developments. And but we are open to talk and see what makes sense for all these there.
Definitely. I think in case you come this year or next year, it would be good we have some meeting with some people, very key people. By that time, we have better understanding of how it is moving. That lot of change from the government and things like that. I think that could make us to set up some type of joint adventures. And if it goes through, if they have interest, you have interest, we can probably tailor some projects in that direction.
100%. Yeah. For example, AI, like Geronimo was talking about, we can always think about how can we advance in that area, or with what Luis was saying in terms of how can we introduce certifiability to systems that we are still in the early phase of introducing such concepts, of course. And then with what Jonas said, how can we bridge the gap of what are the research institutes are doing on AI and how fantastic that is, but in real life, can you certify this? No. What can we do to bridge that gap? So, look, there's a lot.
There is a lot to explore, yeah.
And Rapita as a company with 100 staff, we can't do everything. Plus, we need to maintain the business. So this is where the bright minds here will be the right resource to accelerate such developments.
That's correct. Great. Anybody has any observation, comments, or questions? It's almost 3. I think it's already 7 p.m. in England, probably.
Yeah, that's fine. It's still yeah.
Okay, Hashem, Andrea, thank you very much for accepting our invitation. It was a great talk. I think definitely students enjoyed it. It was good to hear some interactions with you from the students. And I hope we have more chances to interact.
Absolutely. Vijay and Raphael, of course, thanks for joining now here. Appreciate the opportunity to have these discussions. And Andrea, thank you so much for your help. That goes unnoticed. Thank you for the facilitation of the slides and everything else and the organization. Appreciate that. And everyone, thank you for your interactive discussions. Do get in touch with me if you want to chat about anything else that you find useful. I am on LinkedIn. You can find me through Vijay's network. I'll send the slides with my contact information to Vijay in PDF. And then
circulate. Yeah. Okay.
Thank you very much.
Professor Vijay, maybe maybe someone who's on PC could take a screenshot of the meeting, just for we could, and then.
Okay. Hashem, you need to stop sharing the screen. And I can see if I can change the view here.
Okay. We can have a picture. Yeah, international picture. Okay.
Yeah. The issue with Zoom is that I set the screen to have everyone's face. I'm not sure if you're seeing the same thing I'm seeing. Maybe not, but I can take a screenshot. Okay?
Okay.
1, 2, and 3. Another one, just to be sure. Okay.
Thank you.
Thank you, guys. Thank you very much. See you in 2 weeks.
See you in 2 weeks. Okay. Bye, Andrea. Bye, Hashem. Thank you very much.
Have a lovely day ahead. Bye-bye.
Bye, everybody. Thank you.
Bye. Have a good one.